to you guys about the mirror. First, law of reflection is the angle at which the light enters the mirror, which is angle of incidence, is exactly equal to the angle of reflection at which the light leaves the mirror. Ray diagram is a diagram showing the path of selected rays through an optical system. There's two kinds of mirror. There's one concave mirror and convex mirror. Object distance is the distance from the mirror to the object. The value is always a positive number. An image distance is the distance from the mirror to the image. An image can be real, which is inverted and able to be projected on a screen, or virtual, right side up and not to be able to project it on the screen. Last, focal point is the point at which rays or waves meet after the reflection. Next, there is three rays when you're drawing the ray diagram. First, this is parallel ray, and then this is chief ray, and then this is the focal ray. First, parallel ray is a ray from the object parallel to the axis of the lenses. It goes through the focal point on the side of the lens opposite the object. And chief ray passes through the center of the lens, which is right here, and then it is not bent by the lens. Last, focal ray goes through the focal point on the same side of the lens as the object, axis parallel to the lens.
When the object is located beyond the center of curvature, the real image is between the center and the principal focus, making it small and inverted. When the object is at the center of the curvature, the image is small, real, and inverted while at the center. When the object is between the center and principal focus, the real image is beyond the center and is enlarged and inverted. The object is located at the principal focus. No image is formed. All rays are reflected from the mirror as parallel rays. When the object is between the focus and the mirror, the image seems like it is behind the mirror while appearing enlarged. The image is also virtual. All convex mirrors form a virtual image reduced in size.
These are mirror equation derivation. First of all, line A and A prime and B to B prime is intersecting at point C, which means angle of B prime CA and angle of ACF is same. That leads into triangle A prime CB, B prime, and triangle ACB are similar. Through that, we can find that AB over A prime B prime and BC over B prime C is same. Similarly, triangle FB prime A prime and FED are similar. As you can see in the orange grid line, these are similar triangles. According to that, ED over A prime B prime and EF over FB prime is same. Now we can see that if D is very close to P, which means this point of D is going to be same as the point B, P, then it leads to EF equals PF, which means this line and this line is going to be almost same. That leads to BC over B prime C equals PF over FB prime. We can find that BC is same as PC minus PB in this diagram, and then B prime C equals PB prime minus PC. And FB prime is also equal as PB prime minus PF. We can write these whole equation into say another equation, which is going to be replaced by new equation that is deriving from this diagram. And then we can see that PC minus PB over PB prime minus PC equals PF over PB prime minus PF, which is equation 1 in this case. Let PC equals R, and PB equals U, and PB prime equals V, and PF equals F. By sign convention, we're going to make these all as a negative sign. Equation 1 can be written as these formula right here. Continue from the equation 1, we can simplify and written as V's equation, which is called equation 2 in this case. And then now, we cross multiply equation 2, which leads to UV minus UF minus RV plus RF equals RF minus VF. This will lead to these equations. Now in this case, R is equal to 2F. So we can replace all R by 2F, which will lead to UV minus UF minus U2FV equals negative VF. And it finally ends up in equation 3. Now, we're dividing equation 3 throughout by UVF. Then it will lead to 1 over F minus 1 over V equals 1 over U, which is going to be 1 over F equals 1 over V plus 1 over U. In this case, V is image distance and U is object distance.
Hi, I'm Ben.
Hi, I'm Bobby.
Today we are going to do a lab about mirror reflection. The lab we need 4 paints, clay, mirror, the white paper, and a board. Introduction. Reflection and refraction are two of the most commonly observed properties of light. The reflection of light from objects allows us to see them. If the reflection is from a very smooth object like a glass plate or smooth water surface, we can view the image of objects. Refraction occurs when light passes from one medium to another. The path of the light is changed or refracted. This is because the speed of light changes as it passes from one medium into another. The path of light can be described by rays of light.
When setting this experiment up, the first thing you want to do is take your paper and fold it in half so that you have a line in the middle of the paper. Then you want to put your mirror on the line. Then you want to take one pin and put it towards the back of the paper in the middle. The next thing you want to do is take one pin and put it towards the back of the paper like this. Then you want to take another pin and put it as a reference point on either side. The next thing you want to do is bend down so that you are eye level with the paper and you can see the pin in the mirror. Then you want to put another pin in line with the reference point pin and the end of the pin in the mirror. You want to do one for the head of the pin and one for the tail of the pin.
Now I'm gonna mark the pin where I placed the head and the tail. So next we're gonna do the same thing at the other side. First we're gonna take off the pin and place on the other side, same line where the pin we put. And then we see in the mirror from the reflection.
The next thing you want to do is draw a line through from where you saw the reference point to the head, and you want to do this with the ruler because you want a straight as line as possible, and you go through all the way until the end of the paper. You want to do that for where you saw the tail too. Then you want to do the same thing but on the other side of the paper. Then you want to find where the lines from the reference points to the head on each side meet. And you do the same thing for the line from the reference point through the tail. And this is where the pin would be on the other side of the paper. And you want to label this the head and this the tail. The final thing you want to do is measure from where your object is to the center where the mirror was. So about 12.5 centimeters. And that will be the distance of the object. Then you want to find the distance of the image. 13. And that will be labeled the distance of the image. You want to also measure how long the pin is. So 2.6 centimeters. And do the same thing for where you found your image. 2.5 centimeters.
This is our conclusion. After our experiment, we found that our angles of incidence and reflection were actually quite close. The law of reflection states that they should be equal. Our results are close enough within reasonable error to conclude that the law of reflection is true. We believe that the quality of equipment and natural human hands and smoothness easily explain the difference in measurements to account for any error.
Hi, this is Rina. I'm gonna explain the Miller refractions equation. This one is our equation of our Miller reflection. 1 over f is our focal point, equal 1 over dO is our distance of object, plus 1 over di is our distance of image. You can see the question to the next slide. Determine the focal length of the convex mirror that produces an image that is 16 cm behind the mirror when the object is 28.5 cm from the mirror. This one distance of object is 28.5 cm and distance and image is negative 16.0 cm. We want to get the focal point. Let's calculate. Just put the number there. So this is a 1 over f over 28.5 plus 1 over negative 6.0 cm. So just calculate. Then you can get the number 1 over f equal negative 0.0274. Then this one is f equal negative 36.6 centimeter. This one is your problem is your Miller reflection. Then this one is really simple because you only need to use the Miller equation.